Sometimes to understand where we are, you've got to look back at where we came from. And today, we're doing exactly that. We're cracking open a kind of digital time capsule, a single textbook from 1997 to see what it really took to build the foundations of our digital world.
So get this, the full title is Software Development for Engineers, C, C++, Pascal, Assembly, Visual Basic, HTML, JavaScript, Java for DOS, Windows, Windows NT, and UNIX. Whew, that's a mouthful for a reason, right? This wasn't a whole shelf of books, this was one book. The expectation was that a single engineer could know all of it, from the bare metal all the way up to web pages on a bunch of different operating systems. It's absolutely wild to think about today.
And here's our timestamp, 1997. To put that in perspective, Titanic was the biggest movie in the world, and Google wasn't even founded yet. The dot-com boom was just starting to bubble up. This book, it really captures this perfect snapshot in time, right before the web changed, everything.
So, what can this relic actually teach us? What's changed, and maybe more importantly, what's stayed the same? All right, let's open this thing up and find out.
Okay. Our first stop in the time capsule takes us way, way down, right down to the silicon. See, before you could even dream about fancy websites or user interfaces, you had to speak the language of the hardware itself. You couldn't just assume your code would be fast enough. You had to get your hands dirty and get much closer to the metal. To do that, programmers used what's called assembly language. It let them write code that spoke directly to the processor. And the book explains why this was so critical, saying high-level compilers do not always optimize the generated code for speed. So if you needed real performance, say for graphics or heavy-duty math, you often had to write it by hand, one instruction at a time.
And why was that speed so precious?
Well, a really high-end Pentium processor back then ran at about 60 megahertz. Yeah, you heard me right, megahertz, not gigahertz. Every single clock cycle was a resource you couldn't waste. You had to squeeze every last drop of performance out of that hardware.
Now, check this out. This table from the book really shows you the incredible pace of change. It compares how many clock cycles different operations took on older versus newer chips. Look at multiplication and division. An operation that took 144 cycles on an older processor now took just 22. That is a massive leap, and it's this explosion in raw power that really paved the way for the software we use today.
All right, so let's move up a level. All that power under the hood is great, but it's useless if people can't actually use the machine, right? So next up, let's look at how developers were building the windows, the buttons, the things that people actually saw and clicked on. This was a whole new universe compared to the old command line days.
And the key idea here, the huge shift in thinking, was something called event-driven programming. So instead of a program just running from top to bottom, it would basically just sit there and wait. It would wait for you, the user, to do something. Click a button, type on the keyboard, whatever. This is still fundamentally how almost every graphical application we use today works. You can draw a straight line from this 1997 concept to modern tools like React or Vue.js.
And how'd they build those interfaces? Well, with tools like Visual Basic. This here shows some of the standard controls you could literally drag and drop onto your screen to build an application. You've got your scroll bars, your file lists, even simple shapes. These were like the digital Lego bricks for building a program back in the 90s.
And I love this quote from the book's intro. It just sits right to the heart of it. Even back then, the goal was flexibility. The whole point was that the software should adapt to what the user wants to do, not the other way around. That's a design principle that is absolutely 100% timeless.
Okay, now for our last exhibit. And honestly, this might be the most fascinating piece of the whole time capsule. This is where all those other ideas, hardware power, and user interfaces were about to slam into something brand new, the World Wide Web. Let's look at the tools they were using to build it when it was basically a baby.
This is what building a web page looked like. No complex frameworks, no build steps, nothing like that. It was just you and a text editor typing these simple declarative HTML tags. You wanted a paragraph? You typed the P tag. A big headline? H1. It was so beautifully straightforward. You could build a totally functional website with just a few of these commands.
And then there was JavaScript, the language that would, eventually take over the world. But in 1997, its role was much, much smaller. The book explains it was a simple language that just ran in your browser. Its whole job was just to make pages a little interactive, like responding to a mouse click or checking a form before you sent it, all without having to bother the server.
Now this slide is super important because it clears up a huge point of confusion back then. JavaScript is not Java.
Not even close. The book lays it out pretty clearly. JavaScript was interpreted. You just dropped it right into your HTML file. Java was this big, heavy compiled language that ran in these separate things called applets. These were two totally different visions for how the web should work.
And hey, for a bit of fun, check out this little artifact of 90s web design. This is how you set colors, right in the HTML body tag, with these interesting hexadecimal color codes. So this one line here would give you a bright white background with dark orange text and dark red links. A true classic. So, after digging through all of this, what's the takeaway? The tools, the languages, they feel almost ancient now. But what about the ideas underneath it all? What actually endured? Well, I think it really boils down to these three big ideas. First, the power of abstraction, the idea of hiding complex stuff behind a simpler interface. That was true for assembly then, and it's true for cloud APIs today. Second, the importance of the user interface, the realization that we build software for people. And third, the client-server architecture. The web was just getting started, but that model is now the foundation for basically everything.
You know, this quote from the book's preface just says it all. The specific technologies will always change, the languages are going to evolve, but that core mindset of a great engineer, understanding the whole system, from the hardware all the way up to the user, that doesn't change. That remains constant.
And that's a pretty crucial reminder, isn't it? Everything we looked at today was once the absolute cutting edge. It really makes you wonder, what technology that we use every day that feels so permanent right now is going to look just as ancient in another 25 years? What's going to be the next artifact in our digital time capsule?